So in example 2, we want to find the extreme values of the function f of xy equal to 2x plus 5y on the ellipse of x squared over 16 plus y squared over 9 equal to 1. So the level curve of the plane 2x plus 5y is on the straight line in green. And the constraint curve is this curve. First, we're going to identify the constraint curve. That is g of xy equal to 0. So what you do is from these equations, x squared over 16 plus y squared over 9 equal to 1, we're going to move everything to one side of the equations, and we're going to get that x squared over 16 plus y squared over 9 minus 1 equal to 0, and this is g of xy, which is the constraint curve. Next, we're going to calculate the gradient of f and the gradient of g, and then we're going to solve the equations of gradient f equal to lambda times gradient of g. Then we calculate the gradient of f consists of f sub x comma f sub y, and that is equal to 2 comma 5. For gradient of g, you have g sub x comma g sub y, and you get 2x over 16 for g sub x and 2y over 9 for g sub y, or you have x over 8 comma 2y over 9. Then we're going to solve the Lagrange multiplier equations. Gradient of f equal to lambda times gradient of g, and you get that gradient of f equal to 2 comma 5 equal to lambda times gradient of g, which is x over 8 comma 2y over 9. Then from here you're going to obtain two equations. The first equation is 2 equal to lambda times x over 8, and the second equation is 5 equal to lambda times 2y over 9. In each equation, we're going to solve for lambda. So on the first equation, lambda is equal to 16 over x. And in the second equation, lambda is equal to 45 over 2y. And we're going to match these two equations together. We're going to obtain 16 over x equal to 45 over 2y. Or you can solve for y in terms of x, and you get y equal to 45x over 32. Then we're going to substitute y into the constraint equation and solve for x. So substitute y into the constraint equations. And the constraint equation is of the form x squared over 16 plus y squared over 9 minus 1 equal to 0. And therefore we're going to get x squared over 16 plus 1 over 9 times y squared, and y is equal to 45x over 32, so 45x over 32 square, minus 1 equal to 0, and from here you can solve for x. And if you do the calculations correctly, you should get that x is equal to plus or minus 32 over 17. When x is equal to 32 over 17, we have y is equal to 45 over 32 times 32 over 17, or this is 45 over 17. When x is equal to negative 32 over 17, we get that y equal to 45 over 32 times negative 32 over 17, or this is negative 45 over 17. So you have 2 points that you need to consider. That is, so 2 points. The first point is 32 over 17, comma 45 over 17. And the second point is negative 32 over 17, comma negative 45 over 17. And we're going to calculate the output functions at this 2 points. So for f of 32 over 17, comma 45 over 17, you're going to substitute x equal to 32 over 17 and y equal to 45 over 17 into the functions 2x plus 5y, and you get 2 times 32 over 17 plus 5 times 45 over 17. And if we do the calculations correctly, we could get 17 for the answer. Similarly, if we evaluate the output of the function at the point negative 32 over 17, comma negative 45 over 17, we're going to get 2 times negative 32 over 17 plus 5 times negative 45 over 17. And if we do the calculations correctly, this is going to give us negative 17. So obviously we can see that this is the absolute maximum value, and this is the absolute minimum value. And this is another procedure, and I think that is cleaner and easier approach to get the absolute minimum and maximum, absolute minimum and absolute maximum. You can apply either the method in the first example or the method in the second example. It does not really matter. They should arrive at the same answer. But for example 2, the method is a little bit cleaner, but also the problem in example 2 is easier to solve.